Hello, Mr. Ryan, are you right?
Yeah.
On the space, 2D space, xy, right? xy. You know this coordinate. Cartesian coordinate, yeah? This is Cartesian xy, right? So we are given any 4 points. Any 4 points on the space. Can you tell me if we can use these 4 points to make a square?
Yes.
Yeah, roughly, yes, roughly. So how do we check if it's a square? Edges. So edges. But these 4 points, yeah, P1, P2, P3, P4, is not given in order. So it could be P1 here, P2 here, P3 here, P4 here. So as long as these four points combination, we can make a square, then return true. So any idea? I mean, you said edges, the distance. Given 2 points on space, how do we calculate the distance? This here, how do we calculate the distance? For example, look, this one is x1, y1. This one is x2, y2. If we are talking about 2D dimension. So the distance, how do we calculate the distance? Is what? So is this is a triangle, right triangle. Yeah? We talk about this right triangle. Yeah? This is A, this is B, this is C. Remember? Yeah? So what do we have? A square plus B square equals C square, right? Very important. This is right triangle, 90 degree, A and B. So look, this bit is x1 minus x2 or x2 minus x1. Yeah, this absolute value. Okay, this bit y1 minus y2 or y2 minus y1, right? So if we square it plus y1 minus y2 square, and that equal this the distance square equals distance square, right? Look, so how do we get this? So we can calculate the distance. So we just do this square root of both sides, right? So that become d distance equals square root of x1 minus x2 square plus y1 minus y2 square. There are 4 points, so we can just brute force the distance. We calculate the distance between any 2 pairs, any 2 points, and then we put it in a set. So how many different distance do we have if it's a square? Come on, this is the question. If we calculate any pair of distance, how many possibilities? If it's a square, how many possibilities? Okay, so look, maybe my question was not clear. So if we calculate the distance, right? So between any 2 points, so how many possibilities? If it's a square, right? If it's a square, how many possibilities? The values? How about these? The diagonals, right? Yeah? The diagonals are equal. So how many possibilities?
2.
2. Yeah. Yeah, look at these and these. Yeah? Look, these 4, same. The diagonals, the same, right? So simple. 4 points, we brute force the pairs. Yeah, if it's different, like you calculate this distance, and we put it in a set. And if it's a square, then the number of distance, different kind of distance in a set should be 2, right? Because it's big. But there's a very special case. It's not enough. Look, how about if P1, P2, and P3, the 3 values, they are the same. They collide in 1 point. And how about P4 is here? So how many distance here? How many distance? 2, right? Look, 1 distance. P1 distance to P2 is 0. So 0 and that is also 2. So but we have to exclude this situation. Am I right? Yeah? Okay, so the idea is that we compute the distance between all combinations of vertex. There are 4, right? So we can prove of it easily. And then we check the size of the distance set. It has to be 2. And also we check the distance of 0. It shouldn't be any, because if it's any, it means that 2 points or more, they are the same, right? They are the same points. They just collide in space. Okay. So coming back to this is the Cartesian distance for the 2D space, and we can extend this to 3D space as well. Look, what's the distance between this and this? Look, x, y, z, right? For the 3D, look, this is 2D, right? 3D, x, y, okay, if you have to imagine, and z, okay, so 3D space, x, y, z. Okay, let me just write it here. Okay, so there are 4 points, P1, P2, P3, P4, okay? D equals default dictionary. We want to count, right? We don't count the distance, the keys will be distance, the values will be the, how many times of this distance. And then array equals, we put it in the tuple, P1, P2, P3, P4. And then for distance, for I in range 4, right? We are given 4 points. For J in range, I, okay? So then we can calculate the distance of ARI to ARJ. So the distance would be distance, DIST, ARRI, ARRJ. Okay, we come back to this. Okay, distance actually is very simple. Define distance AB, return SQRT square root of A0 minus B0 square times 2 plus A1 minus B1 times 2 square. Okay, this is a distance. So DD. Okay, then we use DD plus equals 1. Right? We calculate the distance with plus equals 1. We count how many times the distance appear in the set. This is a dictionary. Okay, and then at the end we just have to check DD. D0 needs to be 0, right? We don't allow any 2 points that are the same, right? 0, distance 0 should be 0. And length D needs to equals how many? How many distance? 2, yeah. Right? A little bit, right? What's the time complexity if you look at this? Oh, 1, yeah. Because we are given 4 points and we just do some calculation. What have you learned today? What's the problem? What have you learned today?
Learned about the valid square.
We are given 4 points. And we want to check
if it's square.
if we can make a square out of these 4 points, right? So how do we check? We count
The edges.
the distance between the vertex, right? If it's a square, how many kinds of distance do we have? 2, yeah. But also there's a very special case we have to rule out, which is this one. 3 points actually the same, and then there's P4. Because look, if you calculate the distance, there will be 2, right? 0, because the points collide, then the distance is 0, right? That's same. And P1 to P4, another one. Okay? Okay, that'll be for today. Bye bye.
Bye-bye.
Bye bye.